Good morning, friends. It is Tuesday, April the 7th, and we are starting our last chapter. So chapter 4 and 5 will be put together. So we're starting our last chapter. We have 8 more days of this class. It will go by very fast. So again, stick with me. And this is, remember I told you that we were going to start on a high note, and then we were going to go into a valley with chapter 3, and then we were going to end on a high note again. And so chapter 4 and 5 are usually things that people like, that people excel on, and so hopefully this will give you a sense of accomplishment as you do law of sines and cosines. So people do enjoy this. Okay, so we're going to start chapter 4, a couple of housekeeping issues. I went back through all of your tests, gave you back partial credit for things that were maybe in the wrong. It didn't take it by the way you had it, but your solution was correct. A couple of things to note. You have got to use the toolbar on the right. If it says alpha, you have got to use an alpha. If it says beta, you have got to use a beta, not an A or a B. And for some of you guys, that's why it counted it wrong, because you did not use alpha and beta. So again, the toolbar to the right, when we're doing anything in WebAssign, is your best friend. So please be sure to use it. Please be sure to use it, and it will save a lot of trouble. I posted grades in Blackboard as far as I corrected your test on WebAssign, so you can see your corrected score on WebAssign, but your grades at this point, including your test, including everything we've done at this point, are on Blackboard. So you should be able to see that current grade sitting there. So if you have any questions or want to go back through your test, I would be happy to do that. Just send me an email. A couple of people have done that, and that is not a problem. So I don't mind doing that at all. Just send me an email. Okay, so we want to start with law of sines today, and what this is going to do is we're going to solve non-right triangles. So think about everything we've done previously. It's always been based on a right triangle. So to find sides of a right triangle, we use the Pythagorean theorem. To find angles, we used right triangle trigonometry. Those things only work if they're right triangles. Okay, so at this point on, if you don't have a right triangle, you cannot use the Pythagorean theorem. You have to use a different way. So non-right triangles are called oblique triangles. So anything that is not a right triangle. So with oblique triangles, again, you have to solve them by the law of sines and cosines. You cannot use the Pythagorean theorem or right triangle trigonometry. Now, do the law of sines and law of cosines work for right triangles? Yes, it does. Okay, so law of sines and cosines does work for right triangles, but it can't go the other way around. Pythagorean theorem and right triangle trigonometry does not work for oblique triangles. Okay, so think back to high school geometry, triangle congruency. For triangle A, B, and C, there are 6 elements, 3 sides, 3 angles. So given 3 of the 6, we can use law of sines and cosines to solve the other 3. Okay, so here are those theorems. So to get one unique triangle using law of sines, and that's what we're going to look at today, you're going to be given angle, side, angle, and you're going to be given angle, angle, side. Angle, side, angle, and angle, angle, side. Okay, now later in the week we're going to do law of cosines, and there we use side, angle, side, and side, side, side. So that's the information you'll be given. And then we have the ambiguous case, and the ambiguous case is that, okay, it's angle, side, side, and you can call it ass. That's perfectly fine because it is a pain in the ass. And yes, I just said that. I would have said it in class too. The problem with the ambiguous case is it either creates 1 triangle, 2 triangles, or no triangles. So this is kind of our problem child. So it can be solved with the law of sines and the law of cosines. Okay, we're going to solve it with the law of sines today. So because it's such a weird case and it's kind of hard to explain on here, I've also found some really great videos that I've uploaded to our daily assignments that will help you how to determine if a triangle exists and then what to do if it's a 2 triangle case. So those videos should help you if you're given the ambiguous case. So anytime you're given angle, side, side, you're given 1 angle, you're given its corresponding side, and then you're given included side in the middle. Okay, and the reason it's ambiguous is we don't know if this A comes down and creates a triangle. That's what we don't know. So that's what we have to find out. Okay, so the law of sines. In any triangle, the ratio of the sine of the angle and the length of the opposite side is the same for every angle of the triangle. So your triangles are going to be set up to where you have your three angles, and they're capital letters A, B, and C. They're not always in this placement, so they can move around, but your sides will always be opposite your angles. So, and they're lowercase, so angle A, side A. Now, this is the law of sines, and it's the sine of the angle divided by the length of the side. And all of those should be equivalent for each one, for each angle, side combination. Now, it can be flipped over, so you can have your side on top, angle on bottom. If you notice on your green sheet, these are listed on your green sheet for you. You can decide which one you want to use, and it's based on what you learned. I learned to have angles on top, so I tend to do it with angles on top, but know that it also works if they are flip-flopped. Now, something else to remember from high school geometry is when you're looking at your triangle, one way that you can quickly check to see if you got it correct is your largest angle should be opposite your longest side. Your largest angle should be opposite your longest side, and your smallest angle should be opposite your shortest side. Smallest angle should be opposite your shortest side. So then your middle angle should be opposite your middle side. Okay, so that's one way to quickly check to see. So so this is how we do it. So first of all, remember that all your angles of a triangle add up to 180 degrees. Okay, so my given information, angle B, angle C, and angle A. So I've put them on a triangle. So because angle B is obtuse, I chose B to put here. And then we have a side, and then we have an angle. Okay, now you could have put angle C up top here, and that would have still been angle, side, angle. Okay, so we can find angle A by subtracting from 180, all of our angles from 180, and so we get 41 degrees. We then want to set up our law of sines. Okay, so sine of 41 over 12, so this is our A combination, is equal to our B combination. We want to cross multiply. Okay, cross multiply. So B times the sine of 41 is equal to 12 times the sine of 121. Divide by the sine of 41 and you get B by itself. Okay, make sure if your calculator opens a set of parentheses, it closes it. And if you have questions about how to use your calculator, always feel free to email and I can go through that for you. We want to do the same thing for C. I still want to use my 41. I still want to use the one that I know is correct. And then I want to solve for C in this case. So set up your ratios, and then cross multiply. So this is angle, side, angle. The next one, I'm given two angles and a corresponding side. So I'm given two angles and then the opposite side. So this is a case of angle, angle, side. Angle, angle, side. So again, I can subtract from 180 and get my side C. And then from there, I can set up my ratios and cross multiply. Set up ratios and cross multiply. So again, this should be something that's all computational. It's a beautiful thing. So it should be something that you're successful at. Remember, I put the angle sign for angle. Capital letters are your angles, and then lowercase letters are your sides. Make sure to denote your angles with the degree sign. Okay, that's how I will know that that's a degree. Also, as I've created quizzes in WebAssign, it's also, you can see the degree sign. Okay, here's another one. This is angle, side, angle. And again, my two angles I'm given, I know that I'm going to have an obtuse angle, so I saved this C right here for my obtuse angle. And then set it up, angle, side, angle. And then again, set up your ratios and cross multiply. And I'm sorry, I didn't write my B down here. B was 14.003, I think, so I just left it at 14.00. Most things ask for 2 decimal places. Okay, so even if it's 0.00 on WebAssign, if you're doing a quiz, put 00. Okay, so 2 decimal places. Okay, so let's talk about the ambiguous case. So with the ambiguous case, you're given an angle, you're given its corresponding side, and then you're given what's called the included side. So a couple of ways that I refer to this side over here as the hanging side. Okay, the hanging side. I don't know whether it's going to create a triangle, whether it's going to create a right triangle, whether it's not going to have any triangle at all. Okay, you also have your height, and that's how we are going to determine whether we have triangles. So again, I've included 2 additional videos there to help you, and I'll try to explain it as best I can here, but it's helpful to kind of see how to determine that. Okay, so for the ambiguous case, there are 4 and really 5 cases, okay? And what those 5 cases are is, first thing is you want to find your height, okay? You want to find your height, and how you do that is when you drop your height, the shortest distance to any 2 things is a straight line. So if I drop my height, I can use right triangle trigonometry because I've dropped that and become a right angle. So the sine of A is equal to H over B, so opposite over hypotenuse. So once I found my height, okay, if A is less than H, then that means I have no triangle. Okay, it's impossible. That means A never hits the bottom. That means it's not a triangle. If A is equal to H, so if A is equal to H, I have 2 unique triangles. Or excuse me. If A is equal to H, I have 1 unique right triangle. Sorry, my mind was ahead. Okay. Case number 3 is our ambiguous case, and I'm going to come back to that. Okay. Case number 4, if A is greater than B. So if my hanging side right here is greater than my included side. If my hanging side is greater than my included side, that means I'm going to have 1 unique obtuse triangle. And I put number 5 in there is if you're given an angle that's obtuse. Okay, if you're given an angle that's obtuse, that means you're going to have 1 unique obtuse triangle. Okay, and this kind of reflects back to number 4, because if your angle is obtuse, that means A is going to be your longest side, and A is always going to be greater than B then. So, okay, if we go back up to number 3, number 3, if A is greater than H, but less than B, okay, you're going to get 2 triangles. So what happens here, and I tried to draw it out for you here, is we have the pink leg right here. That is A. It's going to swing out and create a triangle over here. So a leg, the A leg swings in for 1 triangle, and it swings out for the other triangle. Okay, so I kind of drew the 2 separate triangles over here. Your pieces are the same for both, but it creates 2 unique triangles. So you can think about that leg as swinging in and hitting the base and swinging out and hitting the base. And again, please watch those videos. They're very helpful, better than I can explain it at this point because they have a few more video things that we can do. So please use the video to determine this. Okay, so there's going to be a lot of writing on this page, so hopefully you can follow it. I tried to color code things a little bit. Okay, so the reason I know that this is angle side is because I am given angle B, side B, and another side. Okay, that's the reason that I know it's angle side. So I'm given an angle, its corresponding side, and then another side. So where all my examples are in A up here, okay, given A, this one's going to be in B, and I did this for a reason, is because your homework is not always in A. And neither are the quizzes, as I saw when I was making it. Okay, so this is angle side, and you know what I'm going to do? I'm about to run out of time on this video, so I'm going to stop this video and do a part 2.